You click a button on a website, right? And you ever just stop and wonder what actually happens next? I mean, it feels totally instant, but behind that single click is this incredible lightning-fast journey. In this explainer, we're going to follow that journey from the very start all the way to the finish.
Yeah, every single one of those clicks, it kicks off this whole complex dance. A request is born and it travels from your screen deep into the hidden heart of an application, and then all the way back. Today, we're going to follow that request step by step to really see how it all works under the hood.
Okay, but before we can even start that journey, we've got to ask a really basic question. Why do we even need a backend at all? I mean, why can't everything just happen right there, in your browser or on your phone? Well, the answer really boils down to one single powerful word: trust. See, the thing is, the front end, that's the part of the app running on your device, it's just fundamentally insecure. Anyone with a little know-how can open up developer tools, mess with the code, intercept network traffic, you name it. You just can't trust it to protect sensitive data or enforce important rules. So because that front end is basically the Wild West, the back end has to step in and be the system of authority. It's the one that has the final say on what's allowed and what isn't. It's where all the real business logic happens. And maybe most importantly, it's the single source of truth that makes sure every single user is seeing the same consistent data. All right, so we get it. The request has to make this trip from the totally untrusted front end to the super secure back end. But how? How do these two totally different worlds even talk to each other? Well, they do it using something called an API, which is basically a stable contract between them. Think of it like a shared language. It lays out a very clear set of rules for how to ask for things and what you can expect to get back. This contract is great because it means the front end and the back end can change and evolve on their own, just as long as they both keep honoring the terms of that agreement. And that right there gets to a really critical point: stability. An API is literally a promise you're making to everyone who uses your service, whether that's your own mobile app or some third-party developer. You break that promise, boom, their apps break, and all that trust, gone. A great API isn't just about what it can do. It's about being a rock-solid foundation that's designed to last. Okay, so our request made it. It's knocking on the backend's front door. But it can't just waltz right in. Oh no. It's got to get past security first. And this security checkpoint has two really important steps that, honestly, people mix up all the time: authentication and authorization. First, the system asks, who are you? That's authentication, proving your identity. Then it asks, okay, now that I know who you are, what are you even allowed to do? And that's authorization, checking your permissions. And this analogy just nails it. Authentication is a one-time thing, right? You show your ID at the front desk, you're in the building. But authorization, that's checked for every single thing you try to do. Every time you try to open a door, the system checks if you have the key. Getting authorization wrong can be an absolute disaster. So, our request made it past security. It's authenticated, it's authorized. Now it gets to enter the core of the application, which you can think of as a kind of logical assembly line where the real work happens. So here's the secret sauce for most modern backends, this really powerful idea called separation of concerns. Instead of having one giant blob of code that does everything, you break the system into layers. Each layer has exactly one job. This is the key to building apps that can grow and change without collapsing into a mess. So let's follow our request down this line. Okay, first up, the request hits the middleware. You can think of this layer as the bouncer to club. Its job is to run quick checks, like logging or rate limiting, before the request wastes any of the application's valuable time. It's your first line of defense. All right, once it's past the bouncer, the request meets the controller. The controller is the translator. It takes the raw, messy language of an HTTP request from the web and turns it into a clean, simple command that the rest of the application can actually understand. It doesn't make any decisions itself. It's more like an air traffic controller, just routing things where they need to go. From there, that nice, clean command gets handed off to the service layer. And this is the brain of the whole operation. This is where all the unique business logic lives. All the special rules, the complex calculations, the decision-making that makes your app, it all happens right here. And finally, whenever that service layer needs to fetch or save some data, it talks to the repository. The repository is like a librarian. Its one and only job is to communicate with the database. And by keeping this task separate, you could swap out your entire database tomorrow for a different one, and you wouldn't have to rewrite any of your core business logic. And that, right there, is a massive win for the long run.
And just like that, the work is done. The database has been updated, the rules have been checked. Now the system has to package everything up and send a response all the way back to your screen.
But wait, there's a catch. You can't just, email a complex chunk of your server's memory over the internet. The web just speaks simple text, so you've got to serialize that data. That's a fancy word for translating it into a universal, flat format like JSON that anything, anywhere can understand and rebuild.
And this is a super important concept to grasp. The data that shows up in your browser is not the actual object from the backend's memory. It can't be. It's a perfect copy, a representation that carries the exact same meaning, but it's been rebuilt from scratch in a completely new place. The original never left the server.
Now, to make this whole round trip even faster the next time you ask for the same thing, backends use a clever trick called caching. A cache is just a small, super fast storage area for data that gets requested a lot. If the data's there, boom, that's a cache hit, and you get it back almost instantly. If not, that's a cache miss. It's a little slower that one time, but the system is smart. It grabs the data and sticks it in the cache for the next person who asks. So, wow, we followed this little request from the moment you clicked all the way through security, down the assembly line, and back again. So what's the big takeaway here? What does all this teach us about building really solid systems? At the end of the day, the biggest lesson is this. A great backend isn't just one giant messy pile of code. It's a well-designed system of layers, and every single layer has a clear, singular job. From the API contract all the way down to the librarian. And the real secret to building amazing systems, systems that can grow, that are secure, and that you can actually understand, is all about one thing: respecting those boundaries.